Welcome to another video of Code and Compile. In this video, we'll talk about XOD. Now, XOD is a software for visual programming language for microcontrollers. So suppose if you're having a microcontroller, or particularly Arduino in this case, and if you are looking for a visual programming tool, this video is for you. Now they call it's like a code, but it's better. Why? Because you have a visual block, and in my belief, if you have a visual block, it's quite easy to troubleshoot a logic. So let's take an example. I have a switch and I want to control my servo motor. To do that, I have a controller named Arduino. Now, most of you might be familiar with Arduino. This is used to link the input and outputs with a compiler. It has a memory in which you can write your program, and it can interface your inputs and outputs. So in this example, we are going to use a software named XOD, and we are going to make the program using visual interface. So let's take an example. Right now I can show you on my table I have a servo motor, and which is controlled by Arduino, and we have some switches and LEDs. So in this example, I'm just showing you what is happening in the circuit. So I have 3 buttons here. So if I press one button, my servo moves in clockwise direction, and if I press the center button, my servo stops, and if I press the right button, it moves in anti-clockwise direction. So this is the example which I have made using this software, and I'm going to explain you in the end of the video how you can make this logic yourself in this visual software compiler. So let's proceed with the very basic example that we need to start and stop the servo motor. Alright, so I will open up my software. Now this software is free of cost. You can download from the website, and you will find the link of the website in the video description. So when you install this software, when you run it for the first time, you will see a window like this. So you can either go to File or create a new project, or if you're already in a new project, you can start making it here. So let's say we want to run the motor using a start button. Okay, so I will put this here. Now I have these 3 buttons here, and I have some LEDs, and I have a servo motor. So right now I'm just going to start and stop the motor using one button. So let's take the first input, and here to take the input you have many functions here. You can take the input from this XOD core, and if you drag down, let me just keep it below. If you drag down, you will find your digital input, which must be here, and just drag it here. This is the one way to take the function. If you're not sure where your function is located, you just double click here and just write what you want. Suppose I want an OR gate. So I will write OR, and we will find your OR gate is here. So right now we don't need it. This is just to explain how you can also find your functions. So I have a digital input. Now digital input, I need to use any of this input. So let's take my input, the button which is in the bottom, and I know its pin number is 44. I hope I'm right. I'm right here, 44. Now this is the properties of this function. If I click here, you will see this inspector window where you can define the port number this function is going to read, and this UDP means it is going to read continuously this input which is coming at port 44. So the input is coming from my button, and now this is going to give me a Boolean output. Now to run my servo, I don't need a Boolean output, I need some value. For example, if I type here servo, you will find a servo functions, which is here. Now in the servo function, if you see the inspector window, we have a port and we have a value. All right. Now the port defines where my servo is connected. I know that my servo is connected at port number 12, so I will write here 12, and the value. Now in my case, my servo start rotating if I put the value 0 or 1 based on the direction, and it stops if I put the value 0.55. But this digital input will not give me a value, it is giving me just a Boolean output. So how do I convert the Boolean into value? You can use an if and else statement. So I will again double click here, and I will search if it has an if and else. Yes, it does have. So click this one, and you have an if and else statement. Now the condition for this function is for sure my button. Now what will happen if this condition is true? If button is pressed, the true will move to my result, which will go to my servo. If this condition is false, the value in the false will go to my result. So I want this servo to rotate, right? So I will put the value here, perhaps 1, and the false, I want to stop the motor, so I will put here 0.55. Okay. So let's see, how does it work? I'm going to deploy this logic into my Arduino. So once you are done with your logic, just click on deploy upload to Arduino. Now here it will automatically select your Arduino board. If it's incorrect, you can select the board whichever board you have. So you can see most of the Arduino board are already present in this software. So I'm using Arduino DUI, and my serial port is automatically detected by the software, which is COM5. So I will compile, debug, and upload. So now you can see the status, your code is being uploaded. If you have any error, you will see the status here. All right, so it will take a couple of seconds before my code is uploaded, and I am using pin 44, I hope. Yes, pin 44, my code is uploaded. So I'm going to press the button here. You can see when I press the button, servo is rotating. When I release, servo will stop because my false condition is going now. When I press, the true value is going to the servo, which is 1, and 1 makes it runs in clockwise direction. And if I release, 0.55 goes inside, which makes it stop. So this is a very small example what you can do in this visual blocks, and I hope it's very easy to understand. When you press the button, true will flow inside. When you release the button, false will flow inside. All right. So this was a very easy example how you can do in this servo. And the steps which I followed was, generally you have to create a wiring layout of your circuit. Now in this example, what we are going to do is we are going to have add some more functions in that. For example, we have 3 buttons here. I want to press one button and release, and my servo should keep rotating in one direction. And if I press the middle button, servo should stop. If I press the right button, servo should rotate in anti-clockwise direction. This is my objective. And I also want to show some status on my LCD screen, you can see here. All right. And I also want status on my LEDs, you can see here, some LED output. Okay. So I have to interlock the direction, show the status on my screen, and show the status on my LEDs with these 3 buttons. That's my objective. So the step 1 is you have to create the wiring layout in some software. The software which I would like to recommend you is Fritzing. In Fritzing, you can define where you want to link your buttons, where you want to link your resistors or LEDs or LCD, so that you can track your pins and then you can create your logic in the real time. All right. Now the step 2 is, once you define your circuit, you have to write down your pin numbers. In my case, the servo is 12 number pin. These are my LED pins and these are my buttons which I would need. So then the step 2 is you have to install the software, which you can download from this website. You have to open it and then you have to write your code in that. Okay. Once you write your code, you have to just compile and upload, and then you have to test your code. So let's do this example, in which the next example in which we'll be controlling the servo. But before that, let's see some more features of the software. So it also supports C++ language to create customized functions. Now you must be aware of the Arduino IDE software, in which you can write the statements. If you're happy with this writing the statements, you can also do it here. Or in fact, you can combine your statements with function blocks. You can do it in together. All right. If you're unable to find your function in the libraries or in the function in the software, you can write your own function and then you can use it. All right. This is one of the amazing features. Rest is it is widely compatible with many hardwares and sensors. For example, accelerometer, thermometers, ultrasonic, servo motor, LCD module. So many of these input and outputs, specific hardwares can be linked directly to the software. And you can code your Arduino using these specific functions. So just for example, I was using a servo motor functions inside my software, in which I just move the value. All right. So these are the specific functions which are already available, which also makes your program quite flexible and very easy to make. And at last, you have another feature that you can upload directly to the board. Now, if I show you here in this software, I have made this FPT, kind of a block diagram. And if I go to my deploy and show code for Arduino, you will notice that this is the code actually which is downloaded into your Arduino. So if you want to make some changes, you can also do it here, because this is the exact replica of what is happening in this code. So this code is directly being downloaded from this software. You don't need additional software for that, which I think is a very good point for using XOD. Now in the next slide, we'll see what are we going to do in today's video. In this video, we will see how to make interlocks in servo direction control. We have to control the direction in forward, reverse, and stop using 3 buttons, which you have seen in my Fritzing diagram. And then you have to indicate the status of servo motor using LEDs. We have 3 LEDs here. We have to use these to indicate the status. And then we have to write the servo operation status on LCD. So this is the function we have to do today. So for that, I need to know my pin assignment. So I will quickly go back and move to this slide. Yes, and then I will go to my programming window here. Okay, so I will close this one for a moment. I will delete this line and delete this line. Okay, so now we have three buttons. You can see here we have forward, we have stop, we have reverse. So I need three digital inputs here. And just to make it look easy, I'm going to rename that. So this digital input, let's call it, this is 44, let's call it stop. So I'm going to type stop, and you can see the indication here. So this is easy to recognize. Now I will copy paste this one using Control C and Control V. Now this should be my forward and pin number 48. Pin number 48, and this goes my forward. Okay, and this is my reverse, and this is pin number 45. So pin number 45, this is reverse. Okay, now the pin mode is automatically defined when you take digital input and write down the pins. So just to confirm, it's 48 for forward, 44 for stop, and 45 for reverse. Very nice. Now, you know we have three values which we need to move in the servo. My servo rotates clockwise when I move 1 in that. It rotates anti-clockwise when I move 0 in that. And it rotates, it just stops when I move 0.55 in that. So I need to move three values. And I need to interlock these values. So how we can do that? So for interlocking, I would prefer you to use flip-flops. All right. Now I'm going to take flip-flop. So this is the search node which comes when you double click here. So you have your flip-flop, and this comes here. Now let's rename this flip-flop for forward. I will write FWT, and I need another one for reverse. Okay. All right, so now I'm using this flip-flop because I'm using the momentary action from my button. I don't have to keep pressing the button. I will press and release. So what this flip-flop will do, when it get a pulse on the set input, it will latch my memory. By latching, I means it will hold the status of memory. This memory will follow the set. If the set is pressed, this will be latched, this will be true. And if there is no signal at the back, so if I connect it here and I press the button and I release the button, this memory will remain true. Okay, this is what we want. And I want to reset this forward when the stop is pressed. And I also want to reset this forward when reverse is pressed. So these two functions should reset my memory, and this function should set my memory. So to do this, what do we need? We need an OR gate, because these are the two stop functions. So I will double click here and click write OR. So I have my OR functions. So I use this OR because I want to reset this forward from stop and also from reverse. Okay, so similar action we will do for reverse. Okay, so this reverse is going to be set by reverse input. I will put it here, and this is going to be reset from forward and from stop. Okay, so this is the kind of interlock we have made. So let me bring it closer. Okay, so what will happen if I press stop? This will be set. If I release stop, this will again be set. If I press stop, it will stop my forward. So if I press reverse, it will set my reverse. If I release reverse, it will remain set. And if I press stop or forward, this will be reset. So this is my interlock. Now we have the signal coming from forward and reverse, but we don't have any signal coming from stop to move the value in the servo. Okay, so what we have to do, now let's consider the if and else statement. Now servo needs three values, 0, 1 and 0.55, but this if else statement can only give two values because we have true and false. So what I do is I'll just take one more of these. Now what will happen, this is a kind of tricky logic if you could understand. What I'm going to do is I'm going to move the value of the top if else to the bottom, and the result I will put to the servo. Now what happens? If this situation is true, okay, if this is true, this true will flow in the servo. Oh, sorry, this is not at port. This is at the value. If this situation is false, the false will flow in the servo. Okay, now let's take this one. If this is true and this is also true, this true will flow in the servo. If this is false and this is true, the false will flow in the servo. Okay, but if this is true or false doesn't matter, but if this is false, the false will flow in the servo. So we have three values coming from true, false, and the false, this one. Okay, so we have three inputs now. I'm going to use this if else false to stop the motor. So this is okay. This is going, when this is going to be false, this will stop the servo. When this is going to be true, I want to move 1, but when this is going to be false, I want to move 0. Now 0 means it's my reverse. So if you're confused what is going on, let me show you what I'm doing. So now when the memory is set, I'm going to put here. Okay, when the forward is triggered, this true will flow from here, and now we need to trigger this one. Okay, we need to trigger this one. So let me do like this at the moment. So when I trigger this forward, this is true. So 1 is true, this will flow from here. This is also true. So this 1 will flow from here. True is linked. This is also flow from here and go to the servo. So servo will be at 1. But if this is false, so 0.55 will flow here, and this false will does not matter because this is flowing down here. So let's just check this example if it is working for us, because we need to make some changes to include the reverse and stop operation. Right now, I did not include stop operation. So what will happen if I press and release the button? The motor will keep running in the start mode. Okay, let's just have it. Let's just have a look. How does it work? Because we are learning how to use the software. So okay, everything is fine. I'm going to press the button now. So I press the button and I release. The motor is continuously running because the 1 is flowing inside. Okay. Now what do we need? Now we need to move stop inside it. We can only stop it if this is false. Okay, so this condition will not come here. So let me just take this condition out. Stop debug. And let me upload it so that my motor at least stops. Okay, I hope it stops. Alright, now we need to include the logic to move the servo motor in reverse and to stop the servo motor. That is possible using these two if-else statements. If this statement is false, then the 0 will flow and the servo will move in reverse direction. If this statement is false, then the servo will stop. So this statement should be false if any of these inputs or both these inputs are off. So when both of these flip-flops are off, this should be off. If any of this is true, then this should be true. So this is very simple OR gate. Okay. So I'm going to take an OR gate and I will put it here. And if you notice, I'm going to put the memory functions here. Now if the forward is true, this is going to be true. So if this is going to be true, the true for the forward will flow from here to the servo. Okay, if the reverse is true, which means forward is false because reverse is going to reset the forward. So this is false, but reverse is going to make this true. So this is false and this is true. So false will go from here and go to the servo. So the servo will get 0. All right. Now if both of these are false, so this is false and this is false. So if this is false, 0.55 will flow to the servo. So let's check this logic now by uploading to the Arduino, and I hope this will work. This is going to interlock the servo to forward, reverse, and stop. So let's see that. Okay, our logic is uploaded. Now we are going to check it. So I'm going to use the buttons here. So this is running in clockwise direction. We can call it forward. In the center button, this is stop because both this flip-flop are reset, and in this is going in anti-clockwise direction. So our logic is fine. Now if I don't press stop, I just press the forward, it will go in the clockwise direction. And here it goes anti-clockwise. This is done using the combination of if-else statement. Now if I press stop, what will happen? This will be false and this will be false. So here I go stop. So servo motor will get 0.55, which will stop my motor. Again, if I press forward, now I press forward, which means this is true and this is true. So this true is 1 and this true is the linked value, which is 1 going to the servo. When I press reverse, this one, now this is false. So 0 will flow here, but this is true because reverse makes it true. So 0.55 will flow, sorry, this 0 will flow, which will move the motor in anti-clockwise, and here it will stop. So this is about interlocking the servo directions. Now all we have to do is we have to indicate the status of the servo motor using LEDs and using LCD. So let's see how we can do that. This in fact is very simple now because we have set reset status. Now when motor is in forward direction, we can turn on this green LED, and this green LED is 46. So what I will do is I will just double click here and take digital output, and digital output I will take here and I will write here green, and this green is going to be set because of this forward, so I'll just give the signal here. That's it, that's your output, and I just have to give the LED number, which is 46, to this port 46 and press enter. Very nice. Now I'll just copy this one and paste here for the reverse and one for the stop, which I can place anywhere where I want. So this green I will rename to blue. Blue color I will take for the anti-clockwise. So I will give the signal here, and the blue LED is 22. So this is 22 here. Now what about the green LED? Now the green LED should, oh sorry, not the green, but the red LED. Now think about it. Now the red LED should be on when the motor is off. Okay, when the situation, when this both forward and reverse are false, then this should be true. Okay, what will happen if any of this is true? This should be false, but if both of them are false, this should be true. This means we need a NOR gate. So here I will take a NOR gate. So NOR gate is going to give output to my red LED, which is 46, 47, red is 47, not 46. I hope green is, yeah. Now this will get the input from my forward flip-flop and reverse flip-flop. Okay, so now if both the situation, both the forward reverse are false, this will get true. You can also take the output from the OR. You can take a NOT gate and give it to red. This is also fine. Because we are already using an OR gate, we can use a NOT gate and give it to this red. That's also fine. Anyway, so let's take the status and let's check the status on our Arduino Upload. So I just used one gate and 3 outputs and we are done. In few seconds we can make the logic. Right now I'm explaining, so it takes maybe some more few seconds, but if I have to do of my own, I can do it much quickly. So the logic is being downloaded and you can see the LEDs here. Right now the red LED is on because the motor is stopped. I hope you can see the red on in the camera. So this is running in one direction clockwise and my blue LED is on. So I think I have to change the numbers. Anyways, this is top. And this is green for anti-clockwise. So I think I took incorrect numbers here. So anyways, this green is for anti-clockwise. What I can do is I can change the numbers here, or I can also change my LEDs. I can reverse it. But anyways, that's not the logic. The main thing we have to understand is how quickly we can make logic in XOD. Alright, so what I'll do is I will just change the LED number and the name. So this green is basically the blue. So green is 46 and blue is 22. So I'm going to put here 22. And wait a second, this green was 46 and 46 was actually blue. So here I will take 46 and here I will take 22. Okay, and then I will download again just to check if everything is okay. Now the next task is we have to give the operating status on the LCD module. Now this should not be very difficult because we are going to use the same logic of if else, because we have three status: motor is clockwise, motor is anti-clockwise, and motor is off. Okay, let's just check that first. Okay, now it's clockwise and green is on. That's fine. This is going to stop, and here it's going to anti-clockwise for the blue. So our logic is fine, LEDs are working. Let's go to the LCD. Stop the debug, double click here and take an LCD module, 16 by 2. So I will take some more space. This is here. Now if you see the 16 by 2, it has two inputs, L1 and L2. L1 is the top row, L2 is the bottom row. Okay, so we also need an if and else conditions for this LCD, but here we have strings, we don't have the numbers. So what we do is we take another if else, and we have if else for the string here. So take it here, and perhaps copy paste this one, take it here, or I can take it one row down. All right, so the same function, when this is false, when this string is false, we have to write motor is off. Okay, when this string is true, we have to write motor forward or motor is clockwise. So I will write in the true, motor clockwise. I have to make sure I don't use more than 16 letters, and in the false, motor anti-clockwise. Okay, well, I need to count. I think this is okay, but I can remove this. That's fine with me. All right, so this will go here, and this will go to my second row. Okay, now condition for this and if else, it's same as this if else. So I can just take this memory, put it here, and condition for this if else is same as this if else. That's it. In this few seconds we have configured our LCD. Now the main thing is we have to put the port, the numbers of Arduino pin, which I should have written here, but anyways I have written somewhere in my note. So I'm going to just put it here, and I will make some changes in the presentation. So my reset pin is pin number 30, and my enable pin is pin number 31. My D4 is pin number 41. D5 is pin number 40, D6 in 39, and D7 is 38. If you want to cross check in my FreeSync, you can also do it by just going to my LCD, and if I go here it says DB4, and if I click this one, you can see pin number 41 is highlighted, which is below the wire, which is okay. And similarly this one is 39, and this was DB6, and DB7 is 38. So this is what I have written here. All right, so what you can do, you can write something in L1. This is the row 1. L2 is linked with these status here. So in L1 I can write the website so that you can remember where you can download the software. Okay, so let's deploy the logic in my Arduino and see the results. This should work fine because I hope our logic is correct. So it will take a couple of seconds to deploy, and our logic is going to be uploaded. All right, so it's uploaded now. Let's check the logic now. So I press the first button, motor clockwise, very nice. You can see the LED is also on, status is also coming, motor is also running. And press the middle button, motor is stop, so motor is off. I press the right button, motor anti-clockwise. Okay, so I hope you like this logic, how we can quickly create some using Boolean, using if and else statement, using FPDs. And the good thing is you can easily track where are you making some mistakes in this visual programming. So this was the objective of today, to tell you, to aware you about a new programming software which you can use in your projects if you're working with Arduinos or any other controllers. And this was all. I just want to say in the end that you just go and install this software and add some flexibility, functionality in your coding applications. It is like a code, but it's a better. So thank you for watching. If you like this video, please like, subscribe, comment, and I hope I'll come with more video tutorials on this software in the future. Have fun.